welcome to the last talk of the day. My name is Tomas, and I usually don't know how to introduce myself, but I work as a software developer, and most of what I do outside of that has to do with art, live art installations, that sort of thing, in one capacity or another. So it usually involves me working in conditions like this, so that the result can look somewhat like that. Above are some of the installations and projections that I've done. Below are some of the more recent installations, like they involve stuff like automatic sewing machines, 3D printers, video calls, all sorts of things. Other than that, I also studied psychology, so I'm happy to see also a fellow student. And I'm interested in HCI, all sorts of things where the computers and humans meet. So be glad to talk about any of that after the talk. And also my main kind of side project is called Abound, and it's this hybrid personal graph database / tool for thought file system thing. The tagline is, by the way, shamelessly stolen from Ted Nelson. I think I've heard the complex, changing, and indeterminate ones before. And while this talk isn't quite about the project, it's sort of the vehicle that I use for exploring the ideas that the talk is going to be about. So we'll get back to it later still. The talk is going to be about connections, about links, and about relations. I use these terms mostly interchangeably, just so it's clear. It's going to be about certain connections that I've noticed throughout certain projects, approaches, and technologies. But it's also going to be about connections themselves and the role they play in transferring meaning across different software boundaries. We're going to be talking about some ideas from Unix. We're going to be talking about files, about file systems, file formats, that sort of thing. And as such, as a talk about connections, there's going to be lots of analogies, because I'm trying to approach this thing from various different angles. So it's going to be about the ways that people, or like that software, is able to transfer meaning. But first, let's talk about files. Files are pretty great. They allow you to, they are basically the chief way you can transfer data across software boundaries. You own them. If you own a file, if you got it on your hard drive, you can do whatever you with it, whatever you want with it. You can store it, change it, save it, so on. So it's no wonder that Unix, there's this concept of everything being a file in Unix, meaning that whatever you want to, whatever you can represent is present somewhere in the file system, and then you can, of course, use your standard set of tools that you use for file management or editors and that sort of thing. You can use it on stuff that's not just files. It can be devices. You can even have an IRC client as a part of the file system. Just an example from Suckless, where basically the software, it creates this virtual file system with virtual files that then you can use, with your standard shell tools, echo, and so on, throughout this file system. Except it's not a file system; it's actually an IRC client. But the thing is that in the everything is a file kind of tenet, it's actually the everything is a portion that's really important. the fact that you have one single representation that you can use the same set of operations on, that you can reason the same way about. And there are lots of examples of everything is A systems. The most kind of powerful and well-known one is from Lisp, where everything is a list, including data and code. And so you can use the same code, you can use the same functions and so on to edit your code as well. Homoiconicity is a great idea. Another example, quite close to my heart, are modular synthesizers. Anybody here who plays with those knows that everything is voltage. So no matter whether you are talking about control voltage, which can be pitch, it can be the pitch of a sound, it can trigger samples, it can be the actual audio data. It's just a cable that goes into some hole and then does things. From this you get the same kind of explosion in modifications that you are allowed with the same interface. The modules might not even be designed to do what you're asking them to do, but they are going to do it anyway, and you can do very interesting things with it. I could go on, but just as an example, there is a page on the C2 wiki listing all sorts of everything is A systems like that. Why this works is that files, voltages, lists, they're narrow wastes. They're what's called narrow, they are part of narrow waste architectures. This is a term originally used in networking, where IP is the narrow waste, as you can see. And the idea is that since every part of the stack has to communicate through this waste, everything in the end has to converge on IP, you can evolve these two parts separately, and you get the same kind of you get the same power. That's one of the reasons why the internet is so long-lasting and works so well. You don't need to do, implement like email over radio or TCP over Sonnet. It's all the same as long as you can get the two halves to communicate over IP. Because otherwise you would get this combinatoric explosion where everything has to integrate specifically with the other things. So in files, this narrow waste is just the interface of bytes, right? No matter what bytes are on the other side, you still get the same set of operations that you can perform, and that's why bytes work so well as an abstraction. The other such narrow waste, specifically in Unix in this instance, is just simple text. It works much the same way. No matter what text it is, no matter what program it comes from, what format it is in, you can perform the same operations, use the same tools. This empowers you as a user or as an operator of the machine. But here already you can see some of the issues with bytes specifically. If you take a look at the specific operations that are allowed allowed through the bytes interface, see if anybody can pick up what's common to all of those. They are essentially they don't carry much semantic meaning. They are essentially all some forms of copying. And now, copying and transfer of data is, of course, an immensely important use case. This encompasses everything from exactly sending over network to saving them to disk and getting it back. You don't want the the hard drive or the network interface to be concerned with whatever you're sending it. You just want it to get a byte stream. But the same thing is here with compressing or encoding and decoding. An equality test in the end of the day, but that's probably the most kind of powerful thing you can do with bytes. You can compare them to see if they are the same. Everything else is almost semantically transparent. There is, nothing that actually you would want to do with the byte stream unless you are just saving it or copying somewhere, because you can't do it. You can only see bytes. You don't see the actual meaning that the bytes encode. And this is an issue because bytes, files, form what's called a bedrock abstraction. This is from LowPro-OS. And the idea of a bedrock abstraction is that the level in a system that's at the bottommost level. It's what everything kind of has to coalesce to. The way LowPro-OS explains it is that it is the bottommost level of abstraction under which no meaningful intervention is ever going to be expected or required of the operator. So the example given is that if you get a program crash, you're going to get, you might get a stack trace. At worst, you're going to get a core dump of the memory, but you're never going to get a transistor dump. You're never going to get a logic gate dump. That's simply below the level of the bedrock abstraction. This is a bit of a like troubleshooting heavy way to think about what a bedrock abstraction is, but I actually like it because it highlights the tension between where does programming end and debugging start and so on. But the key takeaway from the idea of a bedrock abstraction is that the design of it matters. You should, as the operator, should be expected to be able to use the bedrock abstraction. He should be expected, he or she should be expected to inhabit the abstraction level. And as such, bytes are a pretty bad bedrock level. You can't do much meaningful with bytes. And now you might be asking, well, of course, that's also kind of the point and the reason why bytes are so powerful as an interface. But really, there is no such thing in no such packet of data that doesn't actually have internal structure. There is, of course, except ciphertext. There is always some kind of internal structure, even in the cases of files that we might consider kind of bedrocky already, like wave files, which contain just the PCM, samples. If you want to do anything meaningful with a wave file, there is nothing that the bytes abstraction will actually allow you to do. You already need to operate at some higher level of what the data is actually encoding. And the problem here is that why would you want to do it that way? Couldn't we do it couldn't our bedrock be somewhat more meaningful? Couldn't have something so that you can actually use if you're not just copying the data somewhere? And the question is, well, what would the structure look like? Of course, different file formats have different requirements. They are different for a reason, and there is probably no abstraction or no single structure that would encompass all of those use cases, you would think. But we do have it, and it's a link, or rather a link. If you get a link, you can construct a semantic triplet. And if you've got a semantic triplet, you can construct a graph. And if you've got a graph, you can construct pretty much anything. And I just like this to kind of resonate for a bit, because the thing that I'm saying is not that we should do away with bytes, or that we should do away with any kind of or that everything should be semantic triplets. kinda. The levels below the bedrock are still important, and they still play a role. For example, like the efficiency of the transistors is going to concern some of the higher level, it's going to affect some stuff on the higher level. It's just a question of what is the lowermost level that you're actually expected to encounter, throughout the use as as an operator. And there is actually no reason why we couldn't have this level already in our operating systems. Why we couldn't bottom out on this level? In fact, taking just bytes as the bottommost level of the abstraction and turning them into semantic triplets doesn't require you all that much, re-architecturing. You are just taking an abstraction that says you can, it says something that you can point to, and I'm going to turn it into something about something. And that's actually what I'm doing with Append. It's a system where everything is a triplet, and I already use it for categorizing my photos, my bookmarks. This is kind of this is a view. This is more of a file browser view, and I won't dwell too much on it, because this is, for example, another view. It's a spatial view. It's not a spatial view in the traditional kind of graph visualization approach. Like there are no links between those like explicit links, because I think that the spatial computing and relational oriented computing is actually quite related, and the problem, or like the idea that we are all basing our abstractions on a linear text manner is something that I'd like to explore, but that's a story for another time. What I'm thinking, or like my approach, my goal with Append is the end of siloization, among others. Siloization, of course, being the problem where you get data that's stuck within the silos of those applications, when the meaning is only confined within the within the application that understands the data. If everything were were accessible on the level of a triplet, you could point to whatever you wanted in a file. You could take a file and you could, or like not a file really, but like a block of data. It's kind of like the single necessary, not sufficient step towards something more like a graph OS, where everything you are interacting with is actually reachable, and you can grasp it, you can point to it, and you can use it in some other ways, because it would allow you to use the same tools as you use on the file system, except the exact schema that you need to use and what are the exact vocabularies that you need to use. You use something that you find meaningful and it makes sense within that context. We need to find a way of tying those contexts together is the question. So we need to find some way of enabling a pluralism of views on the same data. You might have heard the quote, all models are wrong, some are useful. I'd like to propose all maps, no territories. We need to start thinking about data as, if we are to move forward, we need to start thinking about them as more of like a set of overlapping meanings, and need to find some ways to communicate, how to communicate between them. So one way we could go about that, if you imagine, is if you have these separate kind of separate like pockets of meaning, we would need to find some way to map them. You know, if an example I just today gave actually is if you think about classical music, there is typically a tension between like between the tagging of classical music and popular music, because the classical music has a composer, has an interpret, like a performer, and so on. This is not typically something you would find in popular music, but for most uses, it actually doesn't matter, and you just need to find a way to map between those structures. Or the Zotero we talked about Zotero, the reference manager. There is an extension that you can install to your browser, and if you click it, whatever is on your page is going to get sucked up into the reference database that you can use to then cite or or manage like a bookmark manager. The thing is, the idea is similar. You have some sort of predetermined strict ontologies, strict hierarchy that you are just mapping outside data into. And so there is no need to ask everyone to just find the same standard and use the same standard, because as we all know, standards are great because there is so many to choose from. You only need to kind of establish the pocket of meaning that makes sense for that given use case, and then find a way to map that use case. The question then, of course, is who is going to do that? Who is going to be the arbiter for those, and who is going to write all those mappings, especially if there is going to be so many pockets of meaning? Well, I think the community could do it, and I have a reason to believe it would work. If you heard about sponsor block, if you haven't heard about sponsor block, it's a YouTube extension that people use to mark sponsored segments in videos, and you basically, if you encounter a sponsor, you just mark it, start, stop, and then for whoever is going to be playing the video next, it's going to get automatically skipped. The reason why I'm bringing it up is that this is super fast in my experience. Even like small videos within like 10 minutes of being uploaded already have these segments in them. I think people are really willing to to do this kind of job of mapping and of annotating stuff. It's just that the tools we have aren't really well suited for it. And you might say, okay, well, sponsor block is just for sponsors. Well, there is actually a ton of stuff that you can mark in there. There are self-promotions. There are intermissions, intro animations that you can then skip. There are even jokes. If there is a joke that that you want to skip, you're that dry, then there is actually an option to mark a joke and then skip it. And I've seen like most of the videos that I actually view do have this this level of annotation in them. So I think it is possible, is what I'm trying to say. And the problem with not having these tools, not having ways to point at things, not having some means of annotation, is that we are completely missing some large portions of culture. This is a segment from the Talmud, appropriately also given the date, and you get the levels of commentaries upon commentaries in there. Basically, it starts in the middle and it just expands over there. The commentary culture is very deeply ingrained into this, and what I found particularly charming is that if you mouse over the empty space in this web page demo, you'll get amazing. There still seems to be some blank space. Maybe one day you will fill it on your own. You know, this is a holy text, but it's still like the assumption is that you're going to engage with the text. You're going to be in conversation with it. This brings me to conviviality as a concept, and this quote that I found is I think particularly appropriate for that. Ivan Illich says that I intend conviviality to mean autonomous and creative intercourse and among persons and the intercourse of persons with their environments, in contrast with the conditioned response of persons to the demands upon the man-made environment. This is quite literally a position of discourse and of engagement with the subjects and with the material, rather than being simply subject to whatever whatever you are getting through the internet pipe. By the way, I'm sure conviviality is not such an obscure word. I think there was also a conference with the convivial computing that that might have some overlap with this one. So everything is deeply intertwined. This is from Ted Nelson's Computer Lib, who is also kind of, for me, one of the most important voices in this whole scheme of things about annotations, about how we might look at our documents and the web differently. Because yes, we are still limited we are still artificial limits in the way we interact with our documents, and these impair. They impair us. They make culture less rich. He says that in an important sense, there are no subjects at all. There is only all knowledge and cross connections. Hypertext at last offers the possibility of representing and exploring it all without carving it up destructively. It does offer the possibility. I wish we could take it. And one important thing that I've always thought about this quote is that he explicitly points out that there are no subjects. At the risk of pulling the already thin analogies, even stretching them even thinner, I'd like to have a quote from Wilhelm Flusser, who is talking about the ways we can think about cities. And cities in here are more of a concept bringing about people together in some meaningful relationships, rather than the actual, a geographical place, a town, a city. And he says, I am that to which you is set, which is kind of my how I think about the new way, or like the other way of looking at things, where objects aren't just defined, by their boundaries, like a file is, but more so about the about what you can extract of, or like what you can tell about it. He also says that this image corresponds to other areas. For example, ecology, where, of course, ecological understanding is full of is basically a one big relationship. Molecular biology or atomic physics, where in all cases you get less a well-defined, like classical kind of billiard ball things, like models of the world, and instead you get these cross connections, these overlapping views of the world. And also, if you think about it, even the act of creativity itself is inherently non-hierarchical. It is inherently a connection between two different planes. This is from Arthur Koestler's The Act of Creation, where he describes how any act of creativity is by association. It is taking something that exists in two separate planes and finding a point where those touch, and going on from there, finding something which is not within neither of those planes separately, but finding where they have some meaningful resonance. And of course, that doesn't mean that creativity is impossible with the levels of computing that, or like within the levels of computing that we've got, but it still points to this aspect being very core to all important things, all interesting things that I think we are to content ourselves in the future. And since there is no base level, there is no structure on the base level, we are kind of forced to reinvent languages, serialization, deserialization languages all over again. We are forced to leave this meaning in applications and in their silos, where they are basically inaccessible. Every act that is creative is going to be inherently something that crosses boundaries, and we lose all of that richness in that. And finally, since this is the last talk of the day, I wanted to end this also on a quote from Wilhelm Flusser, from which I'd like to point out. He says that we ourselves should stop thinking of ourselves as subjects, which is why I thought the Ted Nelson's "There Are No Subjects" was interesting. We should stop thinking of ourselves as subjects, and instead of projects, instead of in the sense of projections. And that sounds utopic, which it certainly is, because the new city is not locatable, and it's on the contrary, it is everywhere where humans open up to one another. I thought this was a nice point to end on, given that we are also a city of sorts, and that we are also talking about much utopic things. But at the end of the day, it's mostly about this stuff. It's mostly about taking something and making it something about something, having structure where there is none at the moment. Thank you.
So a little secret is, I already had this idea, and then Rupert came up to me and he said, there's a lot of really good stuff in these talks and all these people in this room. What if we built a community search engine that linked this all together? So I'm glad he pitched me an idea that I had been thinking about, and then you did an entire talk that was like, what if we built a city together? So a lovely ending for the day. Questions? One of the things that I noticed in your talk, there were people who were worried that this was going to be an RDF talk. Let me just say that was a thing that we were worried about. Like, Who here has gone down the dark path of the semantic web? Who here will never go down that path again? Oh.
Yeah.
Alice is giving a talk tomorrow on Blue Sky's app protocol and some of the labelers' work, and I was also reminded of a lot of these things. So I think a lot of people are working on some of these.
Yeah, definitely. Even like I was thinking, a lot of the questions I didn't explore them into great detail, unfortunately. But I was surprised to hear a lot of the questions already in the talks of today. Paul was talking about contextual computing, and I think that append is one attempt at an answer of providing a contextual layer on top of existing ones without having to re-architect everything below. And yeah, there were other resonances as well, I think. Also, tall abstractions. I was thinking like that we need a slightly taller abstraction, at the base of the.
One question about serialization of data. So, in your approach, if I understand you correctly, this can solve the problem of data siloing and this knowledge structure, but I still don't understand why. We will get labels to the silos, but how can we separate them or merge them together to be more accessible?
Right, yeah. Well, another concern with that is that, even if we had this like structural level in our operating systems and languages and so on, it doesn't really like solve the issue in the sense that we could still kind of just have a pointer at a silo exactly. And yes, that is completely possible. And there are of course like there is always going to be like projects that would want to do that, but I think that the overwhelming kind of majority is that it's not done just because it's impossible. It's like the causality is kind of inversed in that I think that if we did have this base level, and if we didn't need to kind of pour everything into bytes and then back again, I think it would come about naturally, because most applications are not kind of opposed. I'm thinking of it almost in terms of like there being like a layer of obfuscation. Like there is always going to be need for that, but if the base level were already more meaningful, I think we just like happen way less often. It's like you would get some level of like mutual understanding, kind of for free, if that were the case.
First of all, thank you. That was really inspiring. I want to talk to you about it later. I'm definitely going to try Upend. I was curious if you had any thoughts on a suitably general data structure for ontological multipolarity.
Once again?
A data structure that can allow you to represent any possible ontology.
Right. Yeah, I think like that's. I think like lots of these problems are actually already solved, like in the terms of like the RDF talk kind of scare. I actually don't like yes, the answer or like the shape of what I'm proposing is pretty much RDF. But if you think about everything else that there is to the technology, it doesn't fulfill that same purpose. And so to answer your question, I think that the data structure, like it could be just just the same. Like it could still be links. After all, like I think OWL is also like composed of triplets. And the technology itself is like, I think it's already there. It's just about so any of the already existing ontologies would probably do. It's just a question of putting them in the right places.
Okay, I have a question. Could you go to the slide where you were showing this application that you wrote?
Yes, but I'd much rather do a demo.
Okay.
Like
Okay.
later,
I mean,
later on.
a demo's fine. That demo's fine.
Or what exactly do you want to know?
So
The thing with this is I purposefully didn't include that many screenshots because, like as I said, this is only one view, and the important view is actually completely absent from the screenshot because it's the view that the underlying application talks with it.
I just wanted to ask if the buttons that are in these panes are they also referable in the schema?
Like the
Like-
operations themselves.
Like detach.
No,
combine?
that's the thing. Like this
Okay.
this is more like a file browser view.
Okay.
So
this is external to the system.
Yes, this is
Okay.
like a view that is external to the system.
Okay. Thank you.
Any other questions? Let's make this the last one. Make it count.
Thanks for the talk. Yeah, I'm very much agreeing with a lot of like what you said in terms of the triple, like entity attribute value, like linking as a more semantically meaningful level for the bedrock abstraction. I was just wondering, given our like computer architectures and like it's not like completely like coincidental. I think that like we have currently bytes as like our bedrock abstraction, and I think we still need to keep it for like performance reasons in like some areas. How like do you see like a good way, and like also I guess like we gotta keep compatibility with like existing ecosystems. Like how do you see like the best way forward, kind of like where like would you like write adapters kind of like for various like existing things and like try to like have like all these adapters speak some common schema, or like how like where at what level like would you try to attack this, I guess?
Yeah, so for performance reasons, as I said, like the bedrock abstraction doesn't necessarily mean you'll do away, you know, with what's already there, like with what's below it. But to answer your question, we've also actually been discussing this with Orion today. My answer even in append is that there is like a level or like there are like layers above these like bytes or impenetrable silos, sort of, that simulate the structure that we would have if, you know, things were native to it. So the example I give with the WAV file, the idea would be that you would have a resolver of sorts that then presents this this universal interface, which are, you know, triplets. And because the idea is much more, or like what I was trying to hint at much more, is that the fact of having one unified interface, one unified look, one unified way to represent things is the important thing, and that the triplets are a nice fit because they are general enough that they might just be it. So yeah, in the like ideal model, it's completely possible that it would be like this would be like virtual, for example, or this would be composed on the fly depending on who is asking.
I've got one more question. And this is kind of also a response to that, because it feels like part of what you're saying here about these relations is not that like everything should be a graph database, right?
Yes, totally.
It's that if you want to represent structure in digital systems, like you need to have more than one thing and a way to relate things together. Like it's just like an informational necessity, right? It doesn't matter how that's implemented, you need those things. And so we have a lot of relations that we do represent in computing, but we don't explicitly represent them as triples. Like when you write a list, you have implicit ordering relations of like A after B after C kind of stuff, right? But that actual relationship is implicit in like the program execution and the compiler and all these like these interactions of many systems together. And so I think my question is kind of a strategic one of, given that we can't go and rewrite decades of computing tomorrow, how can we start to like pretend that computing was structured at a lower level, more in this way, without trying to build a new world from scratch? Like what's the strategic next step that we could all participate in?
Yeah. The answer is kind of similar, like at least in regard to these existing, like integrating what already exists. The practical way I'm going about it in the project is that it exposes an API that replaces the file system and the database. Like so, there is actually one application that I've built that writes like directly. Like it's written against the API of that, and it's basically using it in place of a file system / API. And by the way, it turns out that a lot of problems are actually like really easy if you just have a way of like putting arbitrary kind of values to stuff you can point to. So, like the answer is basically that we would have this, that there would be this these systems, like these instances, append instances, that would be like gateways almost. Like whatever software you want to write directly would use that directly, and it would get access to this like world where stuff is relational, or like where stuff exists relationally. And you said also about the like implicit, or you asked about the implicit orderings, right? Yeah. What I want to say is to that is that it almost feels like it's a kind of a case of like stringly typing. If when you have a system where everything is a string and the information is kind of implicit in the code. How would you move, from that to a properly typed system? You would gradually start replacing, places where strings could act, like replacing the implicit with the explicit in places where it's most necessary.
Thank you very much.